For this lesson, let us use the function f of x equals x cubed minus 3 times x squared plus 1. Be sure to use the asterisk to indicate multiplication. You should use a grid that is about from -5 to 5, as you see here. We will demonstrate the mean value theorem for this function on the interval from -1 to 3. To emphasize this interval, let us go to page 1 of the functions palette and let us set the top function, g, as our function f. Then, we set the interval to range from -1 to 3. Now, we graph this curve. Let us go back to the panel palette and use the plot to functional value button to plot the point of our function at x equals -1. Likewise, we plot the point at x equals +3. Let's open the points palette and note that the bottom 2 points of the previously clicked points box are indeed the points we have just plotted. Therefore, we can click the slope button to discover that the slope of the line determined by these 2 points is exactly 1. You should also notice that we could have arrived at this value by using the calculator on the tools palette and asking for parenthesis f of 3 minus f of -1 parenthesis divided by parenthesis 3 minus -1 parenthesis. Here we see it is indeed the value 1. We would really like to see the line through these 2 points, so let us check to be sure they are still the bottom 2 points of the PCP's box. They are. Therefore, let us open the lines palette and then we can graph the line. At this time, we can get the object select tool, duplicate our line, and then drag it around a little. So, we wonder whether there is a point on the curve at which a line having the same slope will be a tangent line. And it looks like we have found one. Roughly around a small negative first coordinate. Indeed, let us make another copy of our line. And likewise, move it around. And we see that we have found another point. This one, at a first coordinate, a little larger than 2. Remember that the mean value theorem guarantees at least one such point, because f is differentiable on the open interval and continuous on the closed interval. And we have found 2 such points. To find these points analytically, please watch as my human assistant performs for you. I have no idea what my assistant is doing, but hopefully you can follow this scribble. Wow! This is really getting thick. I hope it ends soon. Is the assistant done yet? Okay, I am told I can read from the script again. So, here goes. So, according to the calculus, the derivative of f agrees with the slope of our secant line. Heavens! I have no idea what I am saying. At exactly 2 places. At x equals, well, whatever it is you see here. Let us see if this is true. We use the functional value button. We type parenthesis 6 plus square root 48 parenthesis divided by 6. But before hitting OK, let's make a copy of this entry by selecting it and using Command C. Yes. Note that this matches one of our two positions. Now, let us go back to the functional value button. We will paste, using Command V, our previous entry. But then we change the plus sign to a negative sign. And we select OK. Wow! We see that this gives us our other point. And that is what the mean value theorem is all about. If you return to the points palette, you will see that the bottom 2 points are our points, in case you should need to record them somewhere. I hope you understood this stuff. I know I sure didn't. Anyway, see you next time. Bye-bye.